All right, so it says Dylan has X dimes and Y nickels, having no less than 18 coins worth no more than $1.50 combined. A maximum of 6 of the coins are dimes, and no more than 20 of the coins are nickels. Solve this system of inequalities graphically and determine one possible solution. Okay, so it wants you to determine one possible solution. There are several. Okay, so I want everybody to either turn your computer around or close it unless you have the notes up on it. That's the only reason that we should be looking at it. Because we're going to need to pay attention to this. This is something that you're going to need to watch. Okay. So we're going to go through here first off, and the first thing we need to do is we need to define our variables. Okay. So in this problem, what are X and Y supposed to be standing for? Dimes and nickels. Okay. So what about dimes and nickels? Okay. So is it like the price of a dime? How many dimes, right? Okay. So the number of dimes is our X value, and our Y value is what? The number of nickels. So we have the number of dimes and the number of nickels. Okay. It is important that you define your variables. Okay. A lot of times where people run into some trouble with getting things wrong is they'll write all these equations and the equations are great and they'll solve it fine, and then they mix up the two things that they're talking about because they didn't define their variables. Okay. They might think that X is talking about nickels and Y is talking about dimes. Okay, so define them early on so that you know exactly what it is that you're writing. Okay, so we have to have two equations that we write here. So it says having no less than 18 coins. Okay, so if X is my number of dimes, Y is my number of nickels, and I want to figure out my total number of coins, what am I going to do with those two things? We're going to write an equation, but add them together, right? If I have 10 dimes and 5 nickels, I have a total of 15 coins, right? When I add them together. So I want X plus Y. So having no less than 18 coins. So when I add my coins together, I want no less than 18. So is that going to be greater than or less than 18? Equal to or not? Yes. Okay? So greater than or equal to 18. So that means I can have 18, I can have more than 18, but I don't want to have less than that. Okay, then it says worth no more than $1.50 combined. Okay? Worth no more than $1.50 combined. So how much is a dime worth? How do I write that? 10x. So if I write 10x, that's saying 10 cents. 0.1 or 0.10, right? Is 0.1 and 0.10 the same thing? Yes, they're the same thing. Okay? How much is a nickel worth? How do I write 5 cents? 0.05. Okay, and I want that to be worth no more than $1.50.
So less than or equal to 50.
Okay, less than or equal to $1.50. Okay, then it says a maximum of 6 of the coins are dimes. Okay, a maximum of 6 of the coins are dimes. So, which variable is talking about dimes? X. Oh, that's hard to see. Okay, so do we want more than 6 dimes or less than 6 dimes? Less than or equal to. So, what about if I'm looking at my graph here? Okay, and I know I'm talking about dimes and nickels here. Am I going to go off to the left of the graph or below? Why? We can't have negatives, right? Okay, so technically, all of my dimes are going to have to really be between 0 and 6, right? Okay, because I don't want less than 0 dimes. That doesn't make sense to have less than 0 dimes. Okay, so I just want you to kind of keep in mind that there is this boundary line of our axis in this case because we're talking about a real life situation. Okay, and that real life situation is telling us that we're going to have to be, between the axis and that 6. Okay, so we could even write this and be kind of more accurate. When you go into Delta Math, I think it's going to, it's not going to have you type in a compound inequality. It's going to be assuming that there is that boundary line there. Okay, so just know that when you're doing that. Okay, last part here says, and no more than 20 of the coins are nickels. So what are we going to write for our inequality here? What did y'all say? Okay, less than or equal to 20. And technically, we would want it to be bigger than 0, right? Okay. All right. So we have these inequalities. We need to graph all of these on our graph. So we're going to graph all 4 of them, shade all 4 of them, and then we're going to look at where the shading converges. Okay?
How do you know which 4?
Say it again.
How did you know there was 4? Like there's going to be 4 solutions.
No, there's not 4 solutions. There's 4 equations. There's 4 inequalities that we're going to graph just because when we went through the word problem, we ended up with 4 that we wrote. It's not always going to be 4. It depends on the problem. So you're going to have some problems where it only has 2. You're going to have some problems where it has 3, some where it has 4. You're just going to have to read through the information and make sure that you're writing an equation for all of the information that they gave you. Okay? And what we call these are constraints, right? So these 2, especially on the bottom, those are constraints that we're putting on our system here. All right, so let's graph the first one. So the x plus y greater than or equal to 18. So to be able to graph this, what do we need to do to our equation? Okay, what's your goal with that?
get y by itself.
Okay, so we're trying to put it in what form? Slope-intercept form, right? Okay, so subtract the x over, we get y is greater than or equal to negative x plus 18. How does that help the graph? Okay, so the 18 is what? Okay, that's our where it is on the y-axis. That's our y-intercept. And then the negative x, the number in front of x, is doing what? It's the slope. So it's technically negative 1 over 1. So it's like going down 1 over 1, right? Okay, these are going by 2. So make sure that you are conscious of that when you're doing your graph. A lot of people get into trouble because they don't pay attention to scaling. You really need to pay attention to the scaling of things. So down 1 over 1 is technically going to take on this pattern. Solid or dotted line? How do we know that? Why is that even significant? Why do we even care if it's solid? Okay, so when we're talking about solutions, if it's on a solid line, if I put a dot on a solid line and it's in my shaded solution set, then that is included in the solution set. If it's on a dotted line, those points are not included in the solution set. Okay, so that's why it's important. So there's reasonings for everything that we're doing. Okay, next one, 0.10x plus 0.05y equals 1.50. How can I make this easier to deal with? Multiply by 10. What is multiplying by 10? Okay, so it's going to move my decimal 2 places. Okay, so when you're dealing with decimals, guys, if you hate decimals, get rid of the decimals. All right, so as long as whatever I do to one term, I do to every single term, then it's legal. You can do it. Okay, so if I'm going to move 2 decimal places to make this 10x, as long as I move 2 decimal places on the other 2 terms, then I'm good. So we can turn this into 10x plus 5y less than or equal to 150. You don't have to change it. It's just your preference. If you are in love with decimals, leave it as decimals by all means. But generally, don't want to. So. Okay, then let's move 10x over. We get 5y less than or equal to negative 10x plus 150. And then divide every term by 5. Sometimes we get into a little bit of trouble because we fail to divide every term. Like you'll leave that last term undivided. Make sure that it's every single term. So negative 10 divided by 5. What? Okay, negative 2x. 150 divided by 5. 30. Alright, so let's graph that. Let's go put a dot at 30. Now we're going down 2 over 1. shading. So our first inequality, our blue one here, was y is greater than or equal to negative x plus 18. So how should we have shaded that? Everything on top of it. Now, if you want to like physically shade the whole thing, you can. I get stressed out when I have like 5 different graphs that I'm shading and I can't figure out where it's all coming together. But that's just my perfectionist mind. I don't care if you shade it, shade it lightly, or if you use different colors, or however you need to process that. That's fine. I use arrows, and then I shade at the end. Is the way that I do it. Okay. So what I'll see is I'll draw my arrows of the direction of the shading and then just see where all those arrows are converging at the end, and that's what I'll shade so it's a little bit cleaner. But like I said, however you need to do it. Then we have y is less than or equal to negative 2x plus 30. Up or down? Okay, then we have x is less than or equal to 6. Okay, so the line that we're going to graph is x equals 6. What kind of a line is x equals 6? Vertical line. Okay, how you know, right? The easiest way that I've been able to like just memorize that is if it's x equals a number, I'm going to cut through the x-axis. Okay, like it's going to touch the x-axis. And so it has to be vertical if it's going to touch the x-axis. Okay? If it's y equals, it's going to cut through the y-axis. So a horizontal line would have to cut through the y-axis. Okay? So to me, it's easier to think of it that way to memorize it. So we're going to have this vertical line at 6. Which way are we shading said vertical? Okay, so it's less than 6. So left. And then the last thing is y is less than or equal to 20. So we talked just a second ago, horizontal line at 20. Above or below? Okay, here's where you really have to pay attention. Because so where they're all coming together is going to be this area right here. Okay, but what I want to make sure of is there's this, I don't want to just shade that whole piece. There's that little triangle that's not technically part of my solution set, and I want to make sure that I don't shade that part accidentally. Okay? So don't forget that. Pay attention to details. Draw lots of points so that you can ensure that you're getting your line straight. Okay, so then from there it asks us, Dylan could have blank dimes and blank nickels. So it wants us to pick one solution. Are there a lot of solutions? Yes, right? It's a range of values. There's a lot of solutions in this case. Okay, but what is one? Okay, so 218 would work.
Yeah. 120.
That one's a little bit harder to tell. So if it lies like in this little triangle piece, it wouldn't be a solution. If it falls on that line, it would be a solution. So that one we may have to, yeah, we might have to plug it in to see for sure. But okay, so y'all get the point though. Any of the points inside that gray area would work. Also, any points on the line surrounding the gray area would work. Okay, so we could say 218 would work if we wanted to. Okay, this is a question that I pulled straight off of Delta Math. So if you happen to get this exact question with the exact equations and exact same numbers, I want you to give up and do another one. Okay, there are some questions that it'll pull up that are the same scenario but different numbers. If it's different numbers, do the question. It's not the same problem. But what I don't want is you just plugging in what we did in the notes. That's not going to help you. Yes.
So I saw on